When performing combustion analysis on a two-pipe system, there are considerations we need to take into place. Hold on, let me switch the pump off here. So on a two-pipe system, the air intake could be any given temperature. We need to know what that is so we can get the correct efficiency with our combustion analyzer. This is the Seitron NOVO, and there's two ways we can do this to get the correct temperature. What we got here is a port for a Type K thermocouple. So once you plug the thermocouple in, it's going to take that thermocouple's reading as the temperature reading, not internal to this. Essentially what you're going to do then is put your Type K thermocouple into the intake, because that intake could be anything. That could be 10 degrees Fahrenheit. It could be 20 degrees Fahrenheit. It could be all over the map. We need to know the exact temperature of the intake to get the correct efficiency. I'm going to show you a much easier way to do it on the Seitron NOVO. So if you look closely, you can see that our T air is 54 degrees Fahrenheit. Instead of plugging in your Type K thermocouple, we can do it a little bit more sneaky. So the way we're going to do this is go into settings. We're going to go into air temperature. Now we're going to tap on this box. We're going to change this from auto to manual. And now what we can do is take the temperature of the air outside and enter it in here. I'm going to change it to 75 degrees so you can see what happens. So now it's 75 degrees. Now we're back to the main screen, and you can see that our T air is changed to 75 degrees. Now we're going to get our correct combustion efficiency. Happy HVACing.
Hey guys, I'm in my shop and I'm testing the combustion on my newly cleaned boiler. So I did an annual service. I'm going to show you a really cool combustion analyzer and how it all works. Let's take a look. Okay, so this is my boiler. It heats the floor in the building. The floor is the radiator for the whole space. It's such a beautiful, awesome system. And this is a high efficiency hydronic heating boiler. Okay, it's actually a combi boiler. What I'm going to do is I'm going to focus on this thing kind of strapped to the front of it. What is this? This is a combustion analyzer. We're testing how the boiler is operating for its efficiency, how it's burning the fuel being supplied to it by taking really cool samples of the flue gas out of the flue train before it leaves the building. Okay. So what does that mean? And why do we want to do it? Well, it's pretty simple. We want to test efficiency and actually how equipment is operating for safety purposes. Safety being way more important than the efficiency. We could do that by following some directions. We're going to follow the directions in the manual. The manual for this Viessmann boiler tells you to use the actuator test mode that's built into the control. You're going to force this boiler into low fire, okay? I need it to be at its lowest input rating so we could just get a baseline and see how things are burning and operating while it's on its lowest input. I do have to have that call for heat. Okay, so I've got that call for heat happening. I can dissipate any heat the boiler is producing without overheating it, okay? And that's very important. So I've followed the instructions on the boiler. I've placed it into low fire mode using the actuator test functions of its control. I've zeroed out my analyzer outside of the space. I've got pumped into it clean air, and then I insert it into the flue passageway right here, okay? So it's my exhaust at the end of that wand. It's gonna be right about in the middle of the flue passageway. This little cone kind of allows it to sit in there tight against there. We're not pulling in air from the outside. Okay, so we turn the unit on. It's been analyzing it as it's burning. It's telling us a whole bunch of information, but what in the world does any of this mean? It's analyzing the oxygen levels in the flue gas. It's at 6.5%, and it's kind of bounces a little bit all over the place. It's evening out right now because I had that wand out of the flue gas. You can see it dropping. Carbon monoxide, okay? There's 2.6 parts per million of carbon monoxide in the flue gas stream right now. Carbon dioxide, 8.6%. Efficiency, utilizing some math and equations, it's at 98.5%. That's crazy, right? And there's some other things like difference in temperature of air, going in, going out, things like that. All very useful information. And we can even get a chart view of that by pushing on this touch screen here. Okay, so now we've got all these different colors that correspond to a different value that is being measured, and you can see a graph. That doesn't really help me a lot because I will be completely honest with you. I'm not the foremost expert on combustion analysis. I say that, I've done it dozens and dozens of times, but I don't have these numbers memorized. And for each piece of equipment, it's a little bit different. But what if I told you this Seitron analyzer, the NOVO analyzer, can do something unlike any other analyzer I've used in the past, and it's got this Pro mode. See that right there on the touch screen? I'm going to push it, and now it gives me these little green graphs, these little white pointers on it. It gives me this cool graph that shows CO2, oxygen, CO. It shows me some values that are being measured, and it's even graphing it all out. This is helpful, and here I'm going to show you why. I'm going to push choose equipment. It comes preloaded with a whole bunch of stuff. I actually put Wiesmann in here, and why is that important? So you've got a 70% boiler, 80% boiler, atmospheric water heater. You've got a 70% of furnace, 80% furnace, 90% furnace. I put Wiesmann in here. I'm going to click on that, and I'm going to show you why it matters. See these green bars? They're going to transfer to that other screen, but these are all values that you input. I took numbers right out of the Wiesmann manual for oxygen, CO, CO2. Okay, these are the three values that they're going to give me in the manual for the boiler. Okay, I input those, and then when I select that as the piece of equipment I'm working on, it's going to tell me, with using these green bars and those little white pointers, as long as that white pointer is in the green bar, we're good to go. How cool is that? Now I don't have to know really what this means necessarily. This is all useful information. You will need to reference it. You will need to record this. But for a quicker look, and if you don't suspect your equipment isn't operating right, and you land within all those greens, that means you've landed within the values that you've input into the analyzer that the boiler needs to be at. Now let's take a look at what it means. Like, I'm going to pull that analyzer, the probe out of the flue gas, okay? I'm just going to let the boiler continue to burn, all right? I'm going to just pull it out. And what happens is because that's a very long hose. It's like 6, 8, 10 feet, something like that. It's pretty long. It's got to suck air through that all the way to the pump of the unit, and it's going to start showing us, whoa, those white pointers are no longer white, they're red. They're way off the charts. But what if I put it back in and allow that to pump through that hose back up to the unit? We're going to start seeing these automatically adjust. The boiler's still running. I didn't change anything. We're still on low fire, and look at those. They're going to turn white when they get into the green, and boom. As long as those indicators, that's what it's currently measuring, those little spots on there. 6%, 5.8% O2, 2.2 parts per million CO. That's so entirely low, it's insane. Okay, that number can go up to a couple hundred without real problems. 100 easy. 200 still within reason. Not great, but the lower the better, right? My flue gas is measuring at 77 degrees Fahrenheit, CO2 at 8.6%. Everything is within the parameters that I have input based off of Wiesmann's numbers they're looking for it to be operating properly. Now, if it weren't operating properly, you could adjust things like the gas at the valve, gas input. But we don't need to make any adjustments. I just want to show you this function because, well, that is cool. And obviously, it's absolutely needed. This, to me, is worth the price of admission alone. It's a very nice screen. Seems to work really well. I can print results from it. Okay, I just hit print. It's only the second time I printed. I can't remember quite how long it takes. I think it takes, there we go. Oh. It'll jam up, of course. There we go. Date, time, everything. And we can save this, record it. Usually I would recommend taking a photo of any printed out receipt of this, reports. if you're going to leave this, if you're required to leave this in with the manual for inspection purposes, what I would do is take a photo of that so you have a direct copy of it. This is like heat paper. I wouldn't rely on that forever and ever. It will start to fade and become unreadable. So anyway, there you go. The NOVO from Seitron. And I gotta tell you, this is a very nice, fully featured analyzer with manometer functions. Hey guys, thanks for watching this video. I know it's longer than normal, but if you stuck around to the end, you're seeing this part. And because of that, I want to thank you. I also want to ask you to please hit like and leave a comment, please. If you leave a comment and you like this, it'll help the algorithm find content that you like, and it'll show you more of it. And I would also appreciate the interactions on my posts so it can help other people find it too. Have a good one.
All right, so I'm working on this Turbo Power 96. It's up and running here. Got a few checks that we did before we started the boiler up, but here's the combustion analysis. Here's what you're used to seeing on a combustion analyzer screen. We flip it over to Pro mode. We've set this up to a 90% boiler, so when we come out, we can see everything, our readings still, but we can see we are lined up. Our markers are in the green zone, and it's pretty cool. We have that stoichiometric curve down at the bottom. So something else I'm gonna show you here, we can check our flame signal at FC minus and FC plus. Basically what happens here is that microamp signal will change to a voltage signal. It's referenced in the manual that it will do that, so we can put our meter leads there, set our meter to volts, and go into the DC voltage measurement, and we can see, let me turn the light on for you. So the light on, we can see that we're reading 4.4 volts DC, but that is correlated from 4.4 microamps. Let me set this one up for you, and let's just clarify. So if we're working on an atmospheric boiler, it's drawing all the air that the boiler's using from the boiler room, right? There's no further work to be done to the analyzer to make sure we have a proper efficiency, because it's got a sensor on the analyzer and it's comparing the stack to the room temperature, right? So we don't need to do anything further there, right?
Yeah, absolutely. So what guys don't understand, when I teach classes, right, and I go through how combustion efficiency on every analyzer is actually done is by a variations of three things. Number one, your fuel. It needs to know what you're burning. Number two, it takes the oxygen measurement and calculates CO2 based on the fuel you told it. So that's a thing. And then the third part is actually delta T. It's not one temperature or another. Sometimes guys think it's just stack or something. I go, all those readings on your analyzer actually mean something, right? So they all have a meaning. And every analyzer takes your T flue or T stack, your stack temp. And then you'll see in the reading on there says T air. And then you have delta T. And what the analyzer does is it knows your fuel, calculates CO2, takes your delta T, and that's how we get efficiency.
So I did a van video of showing how you manually set your combustion analyzer, specifically on the Seitron NOVO, to manual mode, so you're actually getting the intake air temperature rather than the room air temperature when you're talking about T air. I just had this thing running and the numbers are just kind of all over the place because I just shut it off. But what I want to do is show you how to do this. So right now my pump is off for the analyzer. So what we're going to do is we're going to go into settings. We're going to scroll to air temperature. We're going to change that to the manual mode. Right now outside it's about 49 degrees Fahrenheit, somewhere in and around there. So what we're going to do is we're going to change that 49. So now our T air reads 49, okay? So now we're going to start this thing up and take a reading. Now this is how you would get your correct efficiency. Otherwise, all you're doing, if you have it in the auto mode, is you're taking the temperature directly from the unit. Now, in this room right now, it's about 74, 75 degrees. So way off of the actual air that the unit's going to be using for combustion. We've now been up and running for a bit, so I will hit the pump. Now we're going to start to get our readings coming in that our probe is seeing.